So we're going to finish up on the last part of 6.2, which is totally separate from unit circle trig. It's trig identities. So just as a reminder, an identity is basically an equation that's true for all values of a variable. It's not an equation that sometimes it works. It's an equation that always works. So I'll go right back to it. But when I tell you that you can flip the sign and get the cosecant, I'm not telling you you can only do that if the angle is a multiple of like 5. You can do it for anything. Okay? If you have an angle of 16.4 or an angle of negative 100.6, it always works because it's an identity. So an identity is an equation that is true for all appropriate values. There are certain values you are not allowed to plug in because you get undefined. Okay, we saw that with the quadrantal angles. All right, so obviously there's things like that. But as long as you don't get undefined, then these work, you're fine. Okay, so there are 3 basic groups of fundamental identities, and we already went through them. There's the reciprocal, which is where you flip one to get a different one. There's your tangent and cotangent, also known as quotient identities. That's where you take sine divided by cosine and it gives you the tangent. Or if you flip it, cosine divided by sine gives you the cotangent. And then the last group of basic identities are called the Pythagorean identities. You don't have to worry about the Pythagorean ones for this test. I just gave them to you so you had all the fundamental ones in the same spot. And most of these, the fundamental ones, like if you take calculus, you need to have these memorized. The 3 on the left are pretty much all you need to know because the 3 on the right are just rearranging the 3 on the left. They're the same thing. These ones we've kind of been doing all along when we do unit circle trig. I told you take the y and divide by the x. That's how you get the tangent, the sine over the cosine. So we've kind of been doing that. These are a little different. But there's a trick, which I'm not going to go over right now. As long as you know that one, you can figure out the other 2. So I have the sine squared plus cosine squared equals 1 memorized. And then if I need one of the other ones, I can always figure it out by knowing the first one. As far as other identities in trig, there's hundreds of identities. You've got like 10 or 11 of them here, but there's hundreds. Basic ones you memorize. Other than that, you look them up. So if, usually in like a calculus book, like the inside cover or right in the back cover or something, they'll have all of these printed. So you can look them up and use them. We're not really going to do anything other than simplify. All right? Because if you were doing a calculus problem, usually the first step is to simplify what you have for a trig problem, and then do the calculus stuff. But you want to simplify it before you start using the calculus. All right? So that's what we're going to practice, just simplifying. So this is one of the Pythagorean identities. Sine squared plus cosine squared equals 1. What I'm showing you here is that you can rearrange that identity any way you want. So in this case, I subtracted sine squared to the other side. That's not a new identity. It's an original one with stuff moved around. And you can do that with any identity, any of them. You can take and move stuff around to make it look a little different. Okay. I also could have put cosine squared on the other side and made 1 minus cosine squared equal to sine squared. Also, as far as the fundamental identity, the basic ones, the reciprocal, tangent, and cotangent identities all work with higher powers. Okay. So let me show you what I mean by that. If you flip the sign, you get the cosecant. Any question on that? Flipping the sign gives you the cosecant. So what do you think would happen if you flip the sign squared? Yeah. You get cosecant squared, right? Because if you think of 1 over sine squared, you could think of it this way. It's 1 over sine times another 1 over sine. Well, 1 over sine is cosecant times another 1 over sine is another cosecant. Cosecant times cosecant, it's just like x times x. It's that thing squared. All right. How about 1 over sine cubed? What do you think that would give me? Chris?
Cosecant cubed.
Cosecant cubed. Yeah. So what I could do, if I wanted, I could go back to those basic identities, and I could really put powers of n on all of them. Okay? If you flip sine to the n, you get cosecant to the n, okay, whatever it is. Okay, I'm not going to write them all in because it'll kind of look a little more complicated, but that's a couple things you can do with basic identities. This and this, they're not new identities. It's just the basic identity to a higher power. So it's not really considered something new. Okay. Any question on that idea? Either rearranging, which again, you're not going to have to worry about Pythagorean identities for this test, or raising to a higher power, which something like this could happen. Okay. In general, the powers don't get that high. Okay. When we start rearranging things, exponents of 2 are about as high as we get. If the exponents get much higher, it gets really hard. All right, so what I want to do is I want to simplify that expression. So this would be like part of a calculus problem where somehow you ended up with this, and now you've got to do some calculus with that. Well, this is kind of complicated because it's 2 different things. If we can figure out a way to combine those into one, we can make it simpler before we go to the next step, which would be something in calculus. So there's a lot of different tricks for simplifying identities. And we're really going to look at one important one for this test. So the trick here is change everything to sines and cosines. And we'll see what happens. Now, this is a trick that works a lot of the time. It doesn't work every time. It's kind of like if you were trying to teach somebody how to play chess. You could give them like a certain move or maybe a trick that works a lot of the time if a certain situation comes up on the board, but you can't say, look, just do this every time and you're automatically going to win the game. Like, if you change everything to sines and cosines, it's not automatically going to work every time. But it will with the kind of problems we're going to start out with. All right, so let's start with cosecant. How can I write cosecant in terms of just sines or cosines? Yep.
1 divided by sine.
Yep, it's 1 divided by sine. So 1 divided by sine times, and now I want to write tangent as sines and cosines. So how would I write tangent just with sines and cosines? Chris?
Sine divided by cosine.
Sine divided by cosine. Now, if you were thinking, well, wait, is there another way you could write tangent? Couldn't you like do it as 1 over the cotangent? Because we talked about that right here. But that wouldn't really help. You could do it, and it might help in some problems, but it's just not going to help in this one. How you figure out what helps and what doesn't help in a certain problem, it's kind of just practice. You kind of start to see certain patterns. And now, if I look at this, and I multiply straight across, what's going to happen there? Yeah.
Sines are going to cancel.
The signs cancel out. Sign in the bottom, sign in the top. As long as you're multiplying, you can always cancel. Just like this. If you want to multiply 3/5 times 7/3, you can just cancel them and say 7/5. Now remember, If it's addition or subtraction, you cannot do that. Addition or subtraction, now you need common denominators. That's a whole different thing. Right? So you can only cancel like that when you're multiplying. So, if I cancel, what's left in the top? 1. And what's left in the bottom? Cosine. Now, there's a simpler way we can write 1 over cosine, so it's not a fraction. What did we say 1 over cosine is? Yep. The secant. So that's basically like substitution. You took this 1 over cosine and you substituted secant. So that's a reciprocal identity. And now all we're left with is this. And that's your answer. So we took something that had two different trig functions multiplied together, and we simplified it to just a single trig function. Now, whatever we had to do next, it's a lot easier to do with just one than what we had originally. That's the basic idea. Any questions on that? Again, they get much harder, but that's, we're just starting out with a couple easy ones, and we're going to spend like a whole week on these later. Okay, let's see. Secant times cosine. Let's take a look at that one. So I'm going to suggest trying the same trick again. Change to sines and cosines. In fact, that's the only trick we know at the moment. Right, so let's start with secant. Someone tell me how I can rewrite secant in terms of just sines or cosines. Kaya?
1 over the cosine.
1 over the cosine. Times, well, the other one already is sine and cosine, so don't even change it. Just leave it. Cosine. What could I put it over if I wanted to make it a fraction so it lines up with the other fraction? Yeah, we could just put it over 1. And now what cancels out there? Yeah, cosine in the bottom, cosine in the top. And you can cancel because you're multiplying. And you're just left with 1 over 1, which is what? 1. So the secant times the cosine is always just 1. So sometimes when you simplify a trig identity, you just get a number. All the trig functions are gone. That doesn't usually happen, but it can. Any question on that one? All right, do I have one? All right, let's try this one. So it's cotangent divided by cosecant. All right. So instead of simplify, I'm going to change the direction to verify. Simplify is pretty much open-ended. They give you a problem, and you just simplify it as much as you can until you think you're done. Verify is actually a little easier. Verify, they give you the answer. I'm telling you that the answer should be cosine. So we know what we're starting with. We know what we're supposed to end up with. You just have to show me why this equals that. So you're never going to touch the right-hand side for this problem. You take the side that looks more complicated, which I think is the left, and try to simplify it so it looks like the right. Right? So let's start with cotangent. How can I rewrite cotangent in terms of sine and cosine? Yep.
Cosine divided by sine.
Yep, it's cosine divided by sine. So I have that. All divided by, now it's cosecant, but I want to write that as sine and cosine. Oh, Blake?
Isn't it just 1 over, or 1 over cosine?
Nope, not 1 over cosine.
Oh, secant, sorry.
1 over sine. So 1 over sine is the cosecant. Now, there's a couple ways you can do it. If you divide two fractions, you can multiply by the reciprocal. And if you do that, what would cancel out?
Sine.
The sines. Right? I just look at it, I see two fractions with the same denominator. I know they're going to cancel out. Now I'm left with cosine in the top. I'm left with 1 in the bottom. And cosine divided by 1 is just what?
Cosine.
Just cosine. So what we've done is we verified that the left-hand side is cosine, and that's what we should have gotten. So again, verify a little nicer, because you know where to stop. Simplify, you don't. Any questions on that one? That's a good one. This one and this type, or something like that, will be on the test. Either a simple multiply or a simple divide. And something will end up canceling out. Any other questions on what we've done with trig identities? Okay. So now let's do the simplified, which I crossed that one off the homework. But let's try it and see what we can do. So this looks like one with higher powers. So when you have higher powers, you've got two options. If you go back and look at your identities, you can either start involving Pythagorean identities, because those have higher powers, and that might work. Or you can just think of the basic identities we've already learned, but with higher powers, right? Since I told you Pythagorean identities isn't on this test, you can probably solve this one without them. You probably can do it with them too, but I think without them is easier. Okay, let's start with secant squared. How can you write secant squared just using sines and cosines?
1 over cosine squared.
1 over cosine squared. That's how you write a trig function squared. You might think it should be like this. Well, that's the same thing. If you just put the number up higher between the argument and the trig function name, that means this. Okay, and then how about the bottom? Tangent squared. Oh, Justin? How about just tangent?
Not sure.
Not sure? Yep, Natalie?
Sine squared over cosine squared.
Right, tangent is sine over cosine. So tangent squared is sine squared over cosine squared. What's going to happen when you divide those two fractions? Yep.
Cosines cancel.
Yep, the cosine squareds are gone. And now you're left with 1 divided by sine squared. Now this isn't a verify, it's a simplify, so we don't really know where to stop. Should we stop there? I think we could go one more step and write this as not a fraction. I think it's always simpler if you can write something not as a fraction than if you have to use a fraction. So what is 1 over sine squared? Wait.
Secant squared.
Not quite.
Saves up a lot.
Yep.
Secant.
Cosecant squared. Yeah, it takes a little practice to get used to them. Right, so we started out with a problem with two trig functions with division, both squared, and we ended up with a single trig function, no division, nothing, just squared. So it's simpler than what we started with. And that's how you do the simplify. Any questions on that? All right. So let's take a look at some of the stuff that is on the test. All right. So first thing we talked about early on was angles, terminal side, initial side, coterminal, Q, obtuse. Make sure you know all those definitions. So let's look at how we could use something like that in a problem. So let's say I'm going to have an angle in standard position. Okay, so you have to know, I'm not going to ask you the definition of standard position, but you'd have to know what it means to do this problem. So let theta be an angle in standard position. All right, so I want you to tell me what quadrant theta is in, and I'm going to tell you a couple facts about theta. I'm not going to tell you how many degrees it is. I'm going to tell you that, let's see. So suppose the tangent of theta is positive. So the tangent of theta is a positive number. And the sine of theta is a negative number. So the tangent of the angle comes out positive, but the sine comes out negative. So we think how we would figure that out. Certain trig functions are positives in certain quadrants, and some are negative. Anyone have a guess before I try to explain what's going on? Yeah? Yeah, it is going to be quadrant 3. How did you figure that out?
Well, it would be a negative for sine, and then to get a negative for tangent, you need 2 negatives.
Yeah.
On top of one, so cosine.
Yep. So
This is why both have to be.
yeah, they both have to be negative. Think of your definitions, right? Sine is the y, tangent is the y over x. So now just look at what's happening. All right, we're saying that the y value is negative. All right, so the y value is negative. That automatically puts you down in either quadrant 3 or quadrant 4. Now, if the y value is negative and the tangent is y over x, then the x value has to also be negative in order for tangent to come out positive. So for tangent to come out positive, that means the x has to be negative, the y has to be negative. Now think about where that would be. Negative, negative, quadrant 3. And that's your answer. All right, so I'll give you a couple facts. I got to give you 2. Because if I just said to you tangent is positive, well, that can happen in 2 spots. You could have positive x, positive y, or negative x, negative y. So if that's all the information I gave you, then you could say there are 2 possibilities, right? But if I give you 2 facts like that, you can narrow it down to 1 possibility. Any questions on that? So something kind of like that. How about let's find the tangent of 147. Okay, how would you find the tangent of 147 degrees? Chris?
You have to find its coordinates. So you can know it's sine and cosine.
That's going to be a tough coordinate to find.
Oh, you just calculate it.
Use the calculator. Can somebody tell me how I knew right away to use the calculator? There's something about that argument that it's not going to be easy. Yeah?
It doesn't fit into 30 or 15 or
Well, it's not a multiple of 30 or 45. Yeah. So if it's not a multiple, then you use the calculator. All right, so we're all set. Tangent 147 gives me negative 0.65. Now, what if I asked for the secant of 12? Is that a problem I would do on the unit circle? Okay?
I was just gonna say you should change it to degrees for reading.
I should change this number to degrees?
Yeah.
Okay, that's an option. You could change 12 to degrees. What else could you do instead of changing the 12 to degrees? But you could. Yep.
Change on your calculator.
Just change my calculator to what? Radians. Right. So usually that's something that people end up messing up because the problems are going to switch between degrees and radians. You just have to look. If there's no circle, you know it's radians. Okay, so I'm in the right mode. How do I type that into my calculator? Yeah.
It would be 1 divided by cosine 12.
Yes, 1 divided by cosine 12. You don't have a secant button, so there is no way to type in SEC. You have to flip the cosine. So 1.19. Any questions on that? Okay, let's look at an angular velocity problem. Actually, you know what? Let's do arc length first. We did that before. What's my formula for arc length? Yep, Natalie.
S equals R theta.
S equals R theta. Now on the test, I'm gonna give you 2 out of 3 of those, and you're gonna have to solve for the third one. So Tori, you can pick which letter do you want to be unknown here? R. Okay, so we're not gonna know R. So let's say we had an arc length of 2 pi inches. And let's pick an angle. Gabe, how big do you want the angle to be?
27 degrees.
27 degrees. Okay. So now the directions here are solve for R. So we're going to plug in. So S is 2 pi. R we don't know. What am I going to fill in for theta? Yeah.
You have to convert it to 7
Yes, because I was given an angle in degrees. That's not what the formula requires. You can still use it, but you got to convert it. So off to the side. What do I multiply by to change degrees to radians? What over what? Blake?
Is it 2 pi over 180? Or pi over 180?
Close, yeah, just pi over 180. Actually, you know what? I'm just going to write that in right here. Okay. 27 is a little bit of a messy number. You could reduce here if you wanted by 3. I'm not really worried about it. I just want to get everything that's in parentheses on the other side. So what could I multiply by to move all that stuff to the other side? Yep, the reciprocal. So you multiply by 180 over 27 pi. Cancels that, cancels that. 180 over 27 pi. So now my pi's cancel, and I just have to do that out. So 360 divided by 27, 360 divided by 27 is about 13 1/3 inches for my radius. So 13.3. Okay, so any question on that one? So you might not be solving for R on the test, but you will be given 2 out of 3 things. What else? All right, unit circle trig. So let's say I gave you the point 1/2 negative root 3 over 2. Okay, that's a point somewhere on the unit circle. The angle it represents, you don't need to know. But it does represent some angle. Let's find the cosine of the angle represented by that coordinate. What would the cosine be? Come on. That would be your sine. That would be your sine. So if this was multiple choice, I would definitely have that as a choice, though. Yep. 1/2. So the cosine is 1/2. Let's do the cotangent. Normally we do the tangent first, so we already have something to flip. This time I don't, so I got to just do the cotangent from scratch. What's the formula for cotangent?
X over Y.
X over y. Cosine over sine. Right? X over y, cosine over sine. And now, let's see, 2's cancel out. Negative 1 over root 3. And what do you get when you fix that?
3 over 3.
Close.
Negative.
Negative root 3 over 3. And there's your cotangent. So I'll give you a coordinate and I'll ask you for a couple of these. Which ones you don't know. It could be the sine, the tangent, secant, could be any of them. All right, let's do a simple one. So theta equals negative 55 degrees. Find a positive and negative coterminal angle. How would I find an angle that's coterminal? And again, this is where you have to know the definition. I'm not going to ask you what's the definition of coterminal, but you got to know what it means to do the problem. Yep.
You for positive, you would add 360.
All right. So negative 55 plus 360 gives me 305.
For negative, you would minus 360.
All right, minus 360. Go back to what I started with. One more time. Negative 415. Now, Robin, you said add or subtract 360. What if you were in radians? What would you add or subtract? What's 360 in radians?
2 pi.
2 pi. So if you're doing it in radians, you want to add or subtract 2 pi. Just stick with whatever units they give you in the problem, if it's a short answer question. All right, let's do an angular velocity. All right. So we have a wheel with a radius of 10 inches. Okay, let's say it's spinning at 350
miles per hour.
I need an angular velocity for this. And then we'll do 350 revolutions a minute. So a wheel with a radius of 10 inches is spinning at 300 revolutions per minute. Right, that's the angular velocity. I want to know how far the wheel would travel. I'm not exactly sure how to word this, but basically if this wheel was spinning on a machine and all of a sudden it came off the machine and it hit the ground and it didn't lose any traction and the wheel just took off, I want to know how far it would travel in a minute. How far it would roll away from you. All right? Assume that it doesn't slow down. I know it would hit like dirt on the ground and it would slow down, but we'll just assume that it just kept traveling at the same speed. So how far would the wheel travel in a minute? If it was rolling on the ground. Okay. So what do I need to figure out here? something I need to know about the wheel that I wasn't given. But I have the information to find it. Okay? I need the circumference, because the circumference represents the wheel rolling one time on the ground, making one revolution. Formula for circumference, you need to know that.
2 pi r.
2 pi r. So 2 pi times 10. So the circumference is 20 pi inches. So now we know how far the wheel rolls in one revolution. How many revolutions is it doing a minute?
350.
350. So this wheel is going to roll 350 times in 1 minute. So what would I do with the 350 and the 20 pi? Yep. Multiply. So 350 revolutions times 20 pi inches in 1 revolution will tell me how far it would roll. 350 times 20 times pi, and that gives me 21,991 inches. And let's say they wanted you to go one more step and convert it to feet. How would you convert that number to feet? You can use dimensional analysis. And if you already know the calculation, you can just do it, which would be to divide by 12. So it's going to roll 1,833 feet, roughly. 833 feet. All right, so you're going to have to chase it a little bit. It's going to roll away. Okay, so any question on that? So you have something kind of like that. Okay, you're going to have a bonus question, which I'm not really going to tell you too much about, other than it's not something we did this week. It's something we did 2 weeks ago. So from last academic week. Okay, and I will tell you one more thing. You need to know how to use a graphing calculator to do it. You can't do it, well you can, but we didn't really learn how to in depth. You need to do it on the calculator. And then the last thing will be an example of an identity. And we practiced a bunch of those today. So an identity either like this one, where you have to multiply two things together, or this one, where you have to divide two things. So a trig identity. Any questions on that, or does anyone want to see another trig identity? No? Okay. So that reviews pretty much what's on the test. So I have a couple trig identities just to practice. We'll do those, and other than that, the only homework tonight is to study for the test.